So this is where we set up experiments using the sediments and the rocks that we collect from the deep ocean. One of the main questions I'm interested in is how much methane oxidizing capacity the carbonate rocks at methane seeps actually have. We know that the sediments are full of these anaerobic methanotrophic organisms, but what's happening inside the rocks? So we need to get these samples up from the bottom of the ocean, occasionally crush them up and put them into bottles like this, and make sure that they're getting the food and nutrients and conditions that they actually need. So that's where the anaerobic chamber here comes in. We need to make sure that there's no oxygen that these microbes are exposed to. That sort of turns off the key cofactor in the enzyme that allows methane consumption to happen. So we need to make sure there's no oxygen, and then we pump this full of methane to make sure that they're happy and have all the food they need. The next part of the experiment is to put larger rocks into gas-tight mylar bags like this. These are often used in the food industry, but this way we can have larger chunks of rocks as opposed to what needs to go into little containers like this. So we set up the specific conditions that these microbes might want: no oxygen, lots of methane, and then see what happens. These are slow-growing organisms. A lot of these incubations take months or years. It looks like I set this one up back in August of 2017, so it's already been about half a year of these guys cooking away. So that's kind of how this process works, all the way from collecting the material from the seafloor, working in the anoxic chamber, getting it into these bags, and seeing what happens.